Alright, in this video we're going to pick up with some differential equations. We're going to be talking about second order linear homogeneous differential equations. So we're asked to find the general solution to the given second order linear homogeneous ODE. So we're given y double prime plus 3y prime minus 4y is equal to 0. And we know this second order because we have y double prime, and we also know that it's homogeneous because it's equal to 0. It would be considered non-homogeneous if it were equal to some function g of x, some non-zero function obviously. And so basically what you have to do with these types of equations is you have to find the general solution by, first of all, identifying what the auxiliary equation is, also known as the characteristic equation, and then you find the roots of that. And then depending on what kind of roots you get, whether you get real and distinct roots, you get complex roots, the general solution will take a certain form. So let me just remind you of the form very quickly for the second order linear homogeneous ODE. So the form for this type of equation is just going to be ay double prime plus by prime plus cy is equal to 0. And remember how we obtain our auxiliary equation, or the characteristic equation is another name for it. Some people call it auxiliary equation, some people say characteristic equation, same thing. And remember the form of that is just going to be ar squared plus br plus c is equal to 0. And basically the general solution will take a certain form depending on the type of roots. So let's just talk about the form for if we have, let's say we have distinct roots. Or real and distinct roots, actually. So if we end up getting real and distinct roots, then the general solution to the differential equation will be c1 e raised to the r sub 1t plus c2 e raised to the r sub 2t, where c sub 1 and c sub 2 are arbitrary constants. If we get complex roots, the solution will take a different form. So form, let's just say we get complex roots. All right, so if we get complex roots, then the general solution will take the form y of t is equal to c1 e raised to the lambda t multiplied by cosine of mu t plus c2 e raised to the lambda t multiplied by sine of mu t. That is the form that I take if we get complex roots. So we just have to determine what kind of roots we're going to get once we identify what our auxiliary equation is. So let's look at our second order equation that we're given, and we'll determine what the auxiliary equation is here. So we got y double prime plus 3y prime minus 4y is equal to 0. So that means that our auxiliary equation is going to be r squared plus 3r minus 4, and we'll set that equal to 0. And what we need to do, basically there's two ways that you can find the roots. The most common way and the easiest way is to factor what you have on this side and then set whatever it is equal to 0 and solve for r. Or the quadratic formula always works as well if you're having a hard time factoring. So those are your options. In our particular case, we can go ahead and factor the r squared plus 3r minus 4. Okay, well, that's just going to be r minus 1 times r plus 4, and we'll set that equal to 0. And you can always check as to whether or not you factored it correctly by simply foiling that. Now, if we solve for r for each of these, it would be r minus 1 is equal to 0, r plus 4 is equal to 0. We'll get two real and distinct roots. So our first root will obviously be positive 1, and our second root will end up being a negative 4. So we clearly get real and distinct roots. So we know what the form the general solution form for our equation. Let me get another sheet. Sorry, my fingers are not the best at grabbing paper. So with that being said, we can go ahead and write the general solution because our roots are real and distinct. So the general solution for our differential equation, so let me write that down for you. So the general solution will be y of t is equal to c1 e raised to, well, since r sub 1 of the first root is 1, we could just write t. You don't have to write a 1 in front of it. And then it'll be plus c2 e raised to the negative 4t. That would be our general solution. Again, the solution will take the form of the solution will, the form of the general solution will be determinant on what kind of roots you get. So in this case, those are the roots that we got here and here. And so therefore, that would have been our final answer. All right, so if you guys got any questions about this, let me know, but that's going to be the answer to this. And I'll see y'all next time.